So I'm Bryan, and I'll be talking about influence maximization under uncertainty. The motivation for this work is something that Melinda and Eric already talked a lot about. Essentially, the application domain is to prevent HIV among homeless youth, where we work with a set of peer leaders, important youth in the network who we can communicate this message to, and the idea is that they'll then influence their peers to spread the message further. And the challenge here that I've been working with is that there's so much uncertainty about the domain because we have so little data. So we don't know the exact structure of the network, we don't know exactly how influence propagates through the network, and we'd like algorithms that are able to select effective peer leaders, even independent of all these things that we don't know. So my work has focused on a couple of areas so far. So first is developing robust algorithms. This is what Millen talked about, where we want algorithms that they give you solutions that perform well in the worst case over everything that you don't know. So even if nature chooses the parameters to hurt you, that you'll still do the best that you can. And then another direction here has been efficient information gathering to reduce uncertainty. So as you can imagine, it's a ton of work to gather network data in these domains. You have to go out and ask all of the homeless youth, who are you friends with, and do this with hundreds of youth. It takes a ton of time. It's really difficult for Eric's students to pull off. And so I've developed an algorithm that strategically explores only small parts of the network, right? So you just ask very limited sets of questions of small numbers of youth, and using only a very little data, you're still able to find out who the influential people are. So you gather just enough data to solve the problem at hand. And so we are conducting pilot studies with LA area homeless shelters, and we find that our algorithms bring about really meaningful improvements so that we can reach many more youth than we could previously using the sort of existing heuristics in the domain. And I'll conclude just by giving a sort of flavor for the general kinds of problems that I'm working on now. And so I'm interested in general robust and risk-aware submodular optimization, right? So the sort of theme through all of this is that there's so much that we don't know about the world, and we want algorithms to optimize, right? To find good decisions for us anyway. And so I'm working on the sort of general properties of solving these optimization problems when you want to make good decisions under uncertainty. And then there's a number of exciting new applications. So things like how do you optimize the structure of a network to promote good social norms, working to prevent childhood obesity with researchers in the medical school here. We're interested in targeting interventions against infectious disease, looking specifically at tuberculosis. We're looking at the problem of optimally allocating public housing to homeless youth. So how do you give a limited supply of housing to the people who will benefit most from it? So these are all really sort of exciting new directions, again, sort of solving optimization problems for how best to use our limited resources to address these kinds of large-scale societal challenges. And then the last thing is large-scale evaluation of these ideas in the real world. So this is something that Melinda and Eric talked about a little bit, that we're starting larger-scale pilot tests with influence maximization algorithms to test out these ideas on a much bigger scale with 900 youth. Great. So hope to see you in the poster session. Thank you.